The same constant force F now moves the block at a constant velocity across a rough horizontal surface from point B to point C, as shown below. Force F acts parallel to the horizontal surface. The magnitude of the constant frictional force acting on the block while moving from point B to point C is 42 newtons larger than the magnitude of the constant frictional force acting on the block when it moves from point A to point B. Calculate the distance from point A to point B. First two paragraphs of the question is mainly about the section between the points B and C. A free body diagram can be drawn as the first step. There is a constant force F pulling the block to the right, and a friction force opposing the motion of the block and acting to the left. Force of gravity and the normal force are ignored in this diagram. They are acting perpendicular to the displacement, therefore work done by these two forces is equal to 0. Usually, the next step which comes after free body diagram is writing the second law of motion. F net is equal to mass times acceleration. According to the free body diagram, the left side of the equation can be written as F minus friction force between the points B and C. Object moves with constant speed. Therefore, value of its acceleration and depending on it, the value of the net force is equal to 0. Hence, force F is equal to the friction force. According to the second paragraph, frictional force between points B and C is 42 newtons larger than the frictional force between the points A and B. We can replace friction BC with the force F as they are equal to each other. It seems that there is nothing left to be derived from the section BC. The question requires to calculate the displacement between the points A and B. There are 4 different forces experienced by the object on this section of the diagram: the force of gravity, the normal force, force F which pulls the block upwards, and the force of friction. Work energy theorem can be used to solve this question, but using the formula for the work done by non-conservative forces can make the solution easier, as there are only 2 forces appear to be non-conservative. These are the forces F and the friction force. Work done by the force F is equal to F times displacement times cosine 0. Both force and direction of the displacement of the block are up the incline. Therefore, the angle between these two is equal to 0. Work done by the frictional force is equal to friction force times displacement times cosine 180. While the block is moving up the incline, friction force is down the incline. Therefore, the angle between the force and the displacement is equal to 180 degrees. In the question 5.4, the work done by non-conservative forces has been calculated as 559.58 joules. Cosine 0 is equal to 1. So, the first part of the equation can be written as force F times the displacement. Cosine 180 is equal to minus 1. The second part of the equation can be written as minus friction force times the displacement. After moving the displacement outside of the brackets, the equation becomes F minus friction force AB multiplied by the displacement. As it was already being calculated in the section BC, F minus friction AB is equal to 42. Displacement is equal to the ratio of 559.58 and 42. Displacement of the block between points A and B is equal to 13.31 meters. 1 mark is allocated for one of these formulas. 1 mark has been allocated for substituting the value of the work done by non-conservative forces. 1 mark has been allocated for identifying the relation between the force F and the frictional force in section BC. 1 mark has been allocated for writing down the relation between 2 frictional forces. And the final mark is allocated for the correct answer.